Chapter 3, Exponential and Logarithmic Functions. We are in 3.5, Exponential Growth and Decay. The objective is to solve mathematical modeling in problem involving exponential growth and decay. So we have two kinds of trend, growth and decay. As we know, growth relates to increasing function and decay relates to decreasing function. As an exponential function can either be increasing or decreasing. Increasing means the number comes from small to big. For example, 1, 2, 3, 4, 5, 6, 7, 8, and so on. While decreasing trend, it comes from big to small number, for example, 10, 9, 8, and so on. The exponential growth is an increasing exponential function, while exponential decay means a decreasing exponential function. So please remember here, growth is about increasing and decay relates to decreasing. The exponential function is a function of the form y equal to a dot b power of x. Note here, a is a non-zero constant, b is greater than 0 and not equal to 1, and x is any real number. So for this, it's important to identify the value of b. If b greater than 1, the exponential function is increasing, or we have exponential growth, and b is called the growth factor. On the other hand, if b is less than 1, the exponential function is decay, and b is called the decay factor. So all about b. It depends on b, whether it is greater than 1 or less than 1. If it's greater than 1, you will have growth function, and if you have b less than 1, it is decay. Example, determine whether the following functions model exponential growth or exponential decay. 1a, y equal to 4 times 2 power of x. Remember, b is the value that has power. Means that your b here is 2. 2 is greater than 1. Since your b value is greater than 1, then the exponential is growth. We have growth function or exponential growth. For b, the value of b here, the growth factor is 0.25, and this value is less than 1, so here we have exponential decay. C, we have 5 to the power of x times 1. It can be rewritten as 5 to the x times 5 to the 1. Means that the equation is like this, 5 times 5 power of x. So the value of b equal to 5, which is greater than 1. So we have exponential growth. So remember, we look at the b value, whether it is greater than 1 or less than 1. Example 2. The number of bacteria present in a culture after t minutes is given by that equation. And t equal to 300 4 over 3t. Does this function represent exponential growth or exponential decay? So to determine the trend, we need to refer to the b value. For this function, b value is 4 over 3. 4 over 3 is greater than 1. Means that the function represents exponential growth. Question number 2. How many bacteria are present initially? Means that we have to calculate the initial time t equal to 0. When t equal to 0, your n will be 300 times 4 over 3 power of 0. Here we substitute the t value to 0 4 over 3 power of 0 is 1, because anything that has power 0 equal to 1. So your n is 300, means that the number of bacteria that present initially is 300. Question 3. What is the rate of growth or rate of decay? For this case, we want to find rate of growth. So, the equation should be written like this. This is the original function given by the question. And we must write the bracket in terms of 1 plus what? Power of t. 1 plus 1 over 3 equal to 4 over 3. How we get 1 over 3? We just need to find the value by writing 4 over 3 minus 1. So we get 1 over 3. That means 1 over 3 is there. 1 plus 1 over 3 equal to 4 over 3. And this is the rate of growth. Your rate of growth is the value of 1 over 3. 1 over 3 is equal to 0.33 in decimal points, and you can always transform this value in terms of percentage, which is 33%. So now the answer for rate of growth is 33%. Remember, we have to write in this format the initial value and then put the bracket, write 1 plus, because this is rate of growth. If you have rate of decay, you must change the addition to minus, 1 minus. But for this case, we use plus. Okay, so the remaining term here, 1 over 3, represent the rate of growth. Okay, now let's look question number 4. Approximately how many bacteria are present after 10 minutes? Notice that t here is measured by minutes, so you can substitute any t value inside the function. So to answer that question, you want to find the number of bacteria present after 10 minutes. So at t equal to 10, your n is 300, 4 over 3 power of 10, and you will get 5327.32. And then you can write your conclusion. The number of bacteria at t equal to 10 minutes is 5327. So in the conclusion, I ignore the decimal point because the number of bacteria should be in whole number. It is illogical to use point for number of bacteria. So from this value, we round out this number, and then eventually the number of bacteria at t equal to 10 minutes is 5327 as the final answer.